Welcome back to this video on structural analysis, where we will explore the use of influence lines for determinate beams. We'll continue from where we left. In this problem, we have a train of 5 wheel loads crossing a simply supported beam with a 22.5 meter span. As we already calculated the maximum positive shear force and maximum negative shear force in previous video, now we'll find the absolute maximum bending moment using influence lines. To accurately determine where the worst-case bending stress occurs, we must first establish the overall behavior of the load system. This requires us to calculate both the total magnitude and the exact geometric position of the single resultant force, represented as R. By summing up all 5 individual wheel loads, we find that the total concentrated force equals 1,180 kilonewtons. Next, we determine where this combined force acts by applying basic rigid body statics and taking a moment equilibrium precisely about the leading wheel load, W1. We set up our equation by multiplying each individual load by its respective distance from the start point. Solving this expression reveals that the resultant force acts at an exact distance of 5.72 meters, measured from the first load, placing it nearest to W3. The standard structural criterion dictates that this maximum moment occurs directly under the heavy load closest to the resultant, when the beam's centerline perfectly bisects the distance between that specific load and the total resultant force. In this problem, our closest heavy load is W3. The distance separating wheel load W3 and the resultant force R is exactly 0.72 meters. Therefore, we must position the entire load train so that both W3 and R sit exactly 0.36 meters away from the center point C. Because the midspan of our beam is 11.25 meters, subtracting this small offset tells us that load W3 must be placed at a distance of 10.89 meters, measured directly from the left support A. In this case, the peak ordinate occurs straight below wheel load W3. We compute this maximum value using the standard structural formula, x multiplied by L minus x, divided by total span length L. Plugging in our values yields a peak ordinate of 5.62. Next, utilizing the principles of similar triangles, we project downward from each remaining wheel load to find their corresponding heights on the diagram. This gives us calculated ordinates of 3.04 for W1, 4.33 for W2, 4.41 for W4, and 3.20 beneath load W5. To find the total cumulative effect, we must multiply the magnitude of each load by its ordinate. Combining all of these individual force calculations together yields a definitive total value of 5,220.20 kilonewton meters. This massive value represents the absolute worst-case bending demand that the beam will ever have to withstand at any point along its span during vehicle transit. Engineers will use this figure to safely select the beam's cross-sectional dimensions. Thank you for watching.